And the last topic in this section is to learn how to rationalize the denominator. It sounds a lot worse than it really is, but what I want to compare it to is let's say you had a question where you left your answer as a fraction and it was 6/8. You should know by now that something like that should be simplified to 3/4. It's improper to leave it as 6/8, even though mathematically these two are equal. Same idea here. We're going to take this and we're going to change it in such a way that we do not have a radical on the denominator anymore. It doesn't change the value of it, like it doesn't change the value of the fraction up here, but it's a more proper way to write your final answer. So the way we do it is we multiply numerator and denominator by the radical that's giving us trouble. So we're going to multiply both top and bottom by √5. The reason we're allowed to do this is because √5/√5, that's equivalent to 1. So really what we're doing is we're taking this fraction and we're multiplying it by 1. And in the process, well, let's work it out. On the numerator, we get 3√5. On the denominator, √5 times √5, well, the roots cancel out. That's just 5. And remember, that's the whole point of this, is we've gotten rid of the square root on the denominator. That's why we choose to multiply it by √5. So if you type this into a calculator, 3/√5, and then you type this, 3√5/5, you're going to get the exact same answer. They're equal, just like 6/8 and 3/4 are equal, but this is a more proper way to write your answer. Same idea with this, 9/√6. We're going to multiply both top and bottom, numerator and denominator, by √6. And when we do that, we get 9√6 on the numerator. And √6 times √6, that's just 6 on the denominator. Now this one we can take one step further because 9/6, the coefficient in front of that radical, is a 9, and it can simplify with the 6 on the denominator to make 3/2√6. Or if you prefer, you can write it 3/2 and a √6 kind of in front. Whether the √6 distinctly shows up on the numerator of the fraction or whether it's in front of the fraction, either one is equal. So this is the process we're going to follow here. We'll get to some more complicated examples in a moment. I just want to mention too, this word rationalize, the word rational means not, it makes sense, like something is rational. It means to make something a ratio. Right now, that 3/√5 or this √6, either one on the denominator, the √5 or the √6, those are irrational numbers, right? √5, if you type it into a calculator, actually gives you value of, let me see here, it gives you 2.236067977 ... and it keeps going forever and ever and ever, and it never repeats. So that √5 is an irrational number. So by rationalizing the denominator, what we're doing is we're taking that irrational number, the √5, on the denominator, and we're making it rational now. 5 is now a rational number. The √5 is irrational because it continues forever and forever and never repeats. So that's just the reasoning for why we use this term, rationalizing the denominator. Just wanted to get that out there. Let's look at some harder examples now. If you ever find yourself in a situation where you have the square root of, and then a fraction underneath, you can always rewrite that as a square root of those individual numbers. So this is equivalent to saying √2/√3 in this first example. And just like we did before, we're going to multiply top and bottom by √3. It's supposed to be a 3. And that gives us a √6 on the numerator. And √3 times √3 is just 3. So we have rationalized this denominator. It looks quite a bit different from the way it did before, but there it is. Type them both into the calculator and they should be the same. Next up with this fraction we have here, the root 5 is the problem. We want to get rid of the root 5. So to do that, we multiply numerator and denominator by root 5. That gives us negative, because there's a negative there, negative 4 root 55, because we do 11 times 5, over, and then root 5 times root 5 is just 5. It's tempting to try to take this further, but we can't. That root 55, we can't bring that any further. Negative 4 over 5 root 55. And this last example, the root 2 is the problem here on the denominator, so we will multiply top and bottom by root 2. And on the numerator, that's going to give us 3 root 12. Denominator, it's going to give us 2. And now from here, you should recognize that root 12 can be broken down. There's a perfect square in there. There's a 4, root 3, over 2. And root 4 is the same as 2. And there's a 2 on the denominator, so those can kind of cancel one another out right away if you want to do it that way. And that leaves us with 3 root 3. If you plug this into a calculator, 3 root 6 over root 2 and 3 root 3, you should get the exact same answer. Here we've eliminated the fraction entirely. Just by trying to rationalize that 2 on the denominator, we've ended up eliminating the fraction. So that's kind of a neat question.